Hey, Polly. You're the only one here so far. We'll get some more here in a minute, though, I'm sure. Oh, here's Olivia. Just kidding. Hi, Olivia. We'll wait for Henry and Maggie. All right, I wanted to pull up, well, I'll just wait, actually. All right, so the first thing I want to do when everybody gets here is go over homework. I'm assuming that you guys have questions on homework. You should have questions on homework if you did it. I also realized I did not send the solutions yet. That's awesome. I will send them in a little bit. I meant to send them last night and I did not get a chance to. All right, so now everybody is here. Henry's joining. Okay, so for homework, you should have been able to check this one, graphing, wait, where are my papers out of? Oh, graphing and properties of ellipses. This is the one that had that thing asking for the lattice rectum, which I don't even know what that is. Never heard of it. It involved graphing, writing the equation of the line. I'm specifically wondering if anybody did numbers 17, 18, and 20, which was a lot of work. And if you know how to do that, that's amazing. If you don't, would you like for me to show you how, even if you didn't do it yet? So basically, here's the deal. If you have not done it yet, then I need to go over this. If you have done it and got this problem right and know how to do it, can you tell me? Like, do we need to see this one? Give me some feedback.
I would like to see it because I can't remember if I did it or not, but is it changing it from standard, like from whatever it is to standard form, or?
Yes, and it involves completing the square, which is like a big.
Okay.
You need help with that?
Yes.
Okay. All right, so let's go over that first. One of the things I said, and you guys saw it because I think I texted everybody, is I don't know for a fact, but I think that some of you, at least if you're following your progression of the school year, you're like running a week behind-ish. That makes it hard for like when I'm teaching you something new because you haven't fully processed the previous lesson. And with math, lessons build on each other. Like for example, today we're going to learn the hyperbola. I'm going to reference ellipses constantly because it's very similar to ellipses. If you have not done any of the homework with ellipses, you're going to be lost today. And this lesson is kind of pointless for you. And so if you guys could try, if you are running behind, and I know you guys have a lot going on, I'm not saying that you don't, but if you are running like a week behind, could you make it a priority to catch up this week? If you need help, I can help you. I worked with a couple of you guys this past week. I'm happy to have you come in a Zoom room by yourself and get extra help that way if we need to, or even meet somewhere if we have to. But I do need you guys, especially as we're like ending this semester, try to stay caught up because otherwise, because once we're done with this class, that's it. Okay, so the directions of this actually say, identify the length of the major axis, the length of the minor axis, the length of the lattice rectum. Let's take a minute and laugh about that because what in the world? And eccentricity. We're skipping the lattice rectum and the eccentricity. I don't even know what they mean by that. In order to find the length of the major axis, we have to know what A and B are, okay? And A and B come from this. This is the standard form. I'm just going to write this once here. A standard form of an ellipse basically looks like this, and then equal to 1. Okay, so we've got to take this whole mess right here and make it look like this. And in order to do that, we are going to need to complete the square. When you've got extra stuff like this, you have to complete the square. Okay, now first step, and I'll try to go slow, like make sure if you're not understanding what I'm doing, ask me to slow down, okay? The first thing I'm gonna do is I'm gonna get my X's and Y's on this side, and anything that is not an X or a Y on this side. That is my first step, okay? And I'm gonna group my X's as I move them over and my Y's. So I'm going to add Y squared to both sides. I'm going to add 8x to both sides. I'm going to add 2x squared to both sides. And then on this side, I'm going to take away 52 from both sides. So on my next line, the first thing I want are my x's grouped together. So I'm going to have 2x squared plus 8x. And then when we're completing the square, you do this, like you make like space for a trinomial initially, okay? And we're going to work through from that and put it in parentheses. And then I'm going to put my y's together. And then over here, I've got negative 52. Okay? Any questions about that? At this point, I'm just moving everything, getting it in position. All right, so when we complete the square, okay, like this, you can't have a coefficient right here. So for this one, the first step to completing the square is taking a 2 out. Here's the thing though, you cannot forget that you have that 2 out there, and I'll show you why in a minute. But I'm just continuing this. I'm just taking a 2 out. Okay, and then I'm not going to rewrite the rest of this. I'm just going to write that under. Now, here's how we complete the square. And remember that we did this for circle problems too, when we're trying to get it in standard form, okay? Don't forget that you have a 2. I generally like to get myself set up, okay? So basically I'm doing this, and then I'm gonna fill in these blanks, okay? Because we're turning this into a square trinomial in order for it to look like this. And this is how it works. You take half of this 4 and you put it right here. Half of 4 is 2, and then when I square it, I get 4 again. Now I just added 4, but here's where this is really important. I really added an 8 because that 2 on the outside technically goes to that. So then I need to add 8 over here in order to balance my equation and keep it balanced. If you don't have a number in front, you don't have to worry about it. And then here we go, half of 16 is 8, and then square the 8 and add it up here. So we go from here to here by taking half and then square it to get to there. So I'm going to add 64. Any questions about completing the square? I had every intention of making like an explanatory video about this, and I didn't, because I can't remember everything because I'm getting too old and tired. But this will be recorded and I can put it on that YouTube channel that I have. Okay, and then what is this? Let's see, negative 52 plus 8 plus 64 is going to be 20. All right, but remember that we're doing an ellipse, okay? And at this point, when we're doing an ellipse, it has to equal 1. All right, that's our goal here, is to make this equal to 1. So what you do is you divide by whatever this is. So all of these are going to get divided by 20. Okay. And then what we have, so if I simplify here, I end up with x plus 2 squared over 10. Here I end up with y minus 8 squared over 20, because nothing reduces, equals 1. And this is the standard form of my ellipse. Okay, now, before I move on and answer the question, are there any questions that you have based on what I just did? At any point, did I completely lose you? You guys are okay? Can I erase yet? Because I'm going to need some space to show you something. Olivia, you look like you're writing. Are you done writing, or do I? Okay. All right, so what I'm going to do now is I'm just going to erase this because I want to show you, since mostly your learning of ellipses was through those videos, which I hope you guys watched. They were made by the same people who made like the unit that I'm using to teach you guys this, which is, in my opinion, a lot better than the way your book teaches it. And so the video should really go right along with what you're being asked to do, like in the worksheets and what you're being required to learn. So what this means, if this is the equation of my ellipse, okay, what this means is the center is at -2, 8. Remember that the minus is part of the formula. So if I plot this, I'm going to go over -2, up 1, 2, 3, 4, 5, 6, 7, 8, just up here. And then you count your major axis and minor axis from there, okay? But these are not nice and pretty. They don't have nice, pretty square roots. But essentially, my a squared is 20. Okay, that's the number under, that's the bigger number. A is always greater than B in ellipses. Okay, so that's how I decide whether this is A or B. And B squared is 10, which means that A is the square root of 20, which would simplify to 2 radical 5. And B is the square root of 10. I'm not going to graph that because I don't really want to, I don't know where those are, but like 2 radical 5 is like 2, a little over 2 from there, and you just draw your ellipse. So, but the question on this one specifically said, what is the length of the major axis? And what is the length of the minor axis? So the major axis, the length of it is 2a. So that's this one. You double this one. 2 radical 5 plus 2 radical 5 is 4 radical 5. The length of the minor axis is b, or 2b, which will be 2 radical 10. So for this one, the only question it's asking is for the length of those axes, but you have to do the entire thing. You have to get it in standard form in order to tell what those are. I think that was probably the hardest one on that worksheet. Are there any other questions from that worksheet, graphing and properties of ellipses, the CUDA software one? What about these? You had 3. You had like homework 3, 4, and the quiz. Yeah, homework 3, homework 4, or maybe homework 3 and the quiz. Were there any questions about those? The quiz kind of encapsulated the circles and the ellipses and foci and all of that. No questions? Okay. If you find that when you catch up, if you're not caught up and you have questions, then you can ask me. We're going to be doing hyperbolas today, which are very much like, hold on, I'm going to try to screen share. Let me stop this. Hyperbolas are like ellipses. They're very similar to ellipses, and So oh, there it is. That's what I want to open. The first thing I want you to do is copy. Well, this is, you know what? Never mind. I'm not going to share that. I think that I'm going to send that to you guys though. So let's start though. We're going to do the same thing we did with the ellipses in that we're going to first learn about hyperbolas, and then and how to graph them. And then we are going to write the equations. The nice thing is, like I said, this kind of goes right along with ellipses. It's very similar. So first of all, let's talk about what a hyperbola is. You have hyperboles in English. These are hyperbolas. And first thing we're gonna do is just establish what a hyperbola is, what the important features are, and then we'll do some problems. So first, there's going to be a lot of notes. I will not erase until you guys tell me I can, but let me know if you need me to, okay? Essentially, a hyperbola, okay, we've got two kinds. We have a horizontal hyperbola, and we have a vertical, and this is what they look like. All right, the horizontal goes like this. It's basically just like sideways parabolas. And then the vertical goes like this. And so there's some special features of this that we'll get into, but that's the general, like that's the main thing you need to know. So get those drawn, and then we're gonna put some stuff on here, add some stuff to it. Okay. So when you're graphing a hyperbola, hold on, I don't want to completely confuse anybody. Center. All right, well, let me show you this first. Basically, when a hyperbola is being graphed, there's kind of like a little box situation that helps know where everything goes. First of all, there are what we call asymptotes, which you guys have learned before. Those are like imaginary lines that the graph will never touch. Okay, so they'll get really, really close, but never actually touch this. And we will learn, like in the hyperbola, one of the things you will have to do is equations for these asymptotes. And sometimes they help guide you for the graphing purposes. The next thing you need to know is where, for the horizontal, this green right there are the vertexes or the vertices. But this is a vertex. This is a vertex. It helps you know like where your little scoop goes from there. And this is going to be a vertex. On the vertical, this is the vertex. So first we're going to get the picture, and then we're going to get some of the kind of the formulas that you need. And those are the only actual intersections with the axes. However, we do have co-vertices, co-vertexes, which end up making like a box with the vertices. So like here and here for this one would be the co-vertex. In the same way that the ellipses had the co-vertex, it's like the B. Okay, when there's A's and B's, it's the B. And then on this one, the co-vertices end up here on the x-axis. Okay. Co-vertex, co-vertex. When we talk about the center, that is going to be right there. It's like the intersection of the asymptotes is the center. The center is also, write this down because we'll get to this in a minute, but the center is actually the midpoint of the foci. Remember foci from, you had foci in the ellipses. The foci in the ellipses were in the inside. Foci in hyperbolas are outside. What color have I not used? Purple. So like here, like in the scoop are the foci, and individually they're each called a focus. And I'll show you in a minute like what that means for those to be the focus, but they're not super important. You don't really need to know. But essentially, if you go from like each focus and you draw a line, you know, coming out, that distance, the D1, like the distance from one focus to the other coming out to the side, it's kind of hard to explain. You'll see it on the notes. I'll let you see it on the notes later. That's like how we determine the hyperbola, but it's not super important that you know that. You mainly need to know that we're going to use these points for figuring stuff out. Okay. All right. So I'm going to give you a minute to finish drawing that picture. If you could either give me a thumbs up if you're on camera or tell me in the chat when you are done drawing these pictures so I can delete it. All right. Olivia and Henry are done. Maggie and Polly. Maggie's done. Polly, have you drawn these pictures? You can tell me in the chat. I don't know. I'm gonna clear. Okay. So next thing, let's get some formulas. Okay, so these are formulas in standard form and all that jazz. Okay, for a hyperbola. So let's start with standard form. With the center at 0, 0. The other thing, let's see. So you know how in the ellipses, the A, which was the major axis, was always under the like X or Y, depending on which direction it went. The hyperbolas are a little bit different, okay? The horizontal hyperbola, so this is the one that's like this. In this one, the A is under the, oops, hold on. The A is under the X squared. And then it's minus instead of plus. In ellipses, that's a plus. It's X squared over A squared minus Y squared over B squared equals 1. That's for the horizontal one, the one where that center is like right here and here, and that's how it goes, okay? Then the vertical, remember, goes like this and like this, okay? So for the vertical, the vertexes are on the Y, okay? So that helps you remember that when you're writing the equation for this one, the Y comes first. But the A squared and the B squared do not change. Okay, but the Y will come first. Okay, so and remember that this is why I was saying, like, if you haven't done the ellipses, some of this instruction is going to be confusing because I'm going to keep comparing. But in the ellipses, the A and B switched places. In the hyperbolas, the X's and Y's switch places. So if the Y comes first, that makes it a vertical. Okay. Let's see. And then the vertices for this, the vertex, I don't know why I just put that. The vertices will be over A up 0 and negative A 0. Those are the vertices for this one. The vertices for this one are going to be over 0 up A, 0 negative A. And I'll tell you, for all the years that I've done conic sections, a lot of times I do not have this kind of stuff memorized. I do a little bit more now, but I am fine with you guys accessing your notes for figuring all of these things out. Memorizing this is just kind of a little bit of a waste of time. But you do have to have good notes so that you can use them. In this case, the co-vertices will be over 0 up B and over 0 negative B. And over here, those co-vertices are actually on the x-axis. So it's B0, negative B0. And then, of course, we have to do the foci. So remember with the parabolas, not the parabolas, the ellipses, focus was c squared equals a squared minus b squared, I think. With the hyperbola, to get our c, which is our foci, we have c squared equals a squared plus b squared. And your foci, just write this. It's basically all you need to know is that the foci are plus and minus c units from the center. So again, we're gathering all these notes and information, and then we will do some problems with this, okay? Let you guys get that copied down. Give me a thumbs up when you're done. You done, Maggie? All right. Okay, so we need two more pieces of information here. Okay, so now standard form. When the center, I'm going to make a C there, is HK. Okay, so it's going to go like this. So the horizontal one is this, x minus h squared over a squared minus y minus k squared over b squared equals 1. And then the vertical, remember, so it's basically going to be the same thing, but we switch the x and y. So we have y minus k squared over a squared minus x minus h squared over b squared equals 1. That is when you have the center at HK. And then I have one more formula for you. One that we did not have to do when we did ellipses. So the last thing that you will need to know is the equation of the asymptotes. And this will make more sense when I do an example. Right now, it may not make an example. It may not make any sense. For the equation for the asymptotes, for the horizontal one, that's why I keep this under the horizontal, it's y equals plus or minus b over a times x minus h plus k. This will make, this is actually not that hard. It kind of probably looks like it right now, but when we actually do this, you'll see it's not too bad. And then y equals plus or minus a minus b times x minus h plus k. That plus or minus indicates that you're going to have two answers. There's two asymptotes, because remember they cross. All right, so when you get that written down, you can give me a thumbs up. I saw Olivia's thumbs up. Did anybody else do a thumbs up? Okay. All right, so let's actually work a problem. We ready? Ready or not? Okay, so you're equipped with all of your notes. Okay, so the directions here, and this is also exactly like what you're gonna see on your homework, okay? The directions say this: graph the hyperbola, and then you're going to identify the following: the center, the vertices, the co-vertices, and the asymptotes. Okay, so a lot of this is just using the formulas. But let's start. So our first example is we're going to do x squared over 4 minus y squared over 9 equals 1. All right, and I'm going to show you how we work all this out and how we graph this, okay? I'm just erasing these. These are just the instructions for this. Okay, so first of all, I'm just going to draw a blank graph over to the side. We're not going to do a lot with the graph yet, but we can go ahead and like if there's an x squared over 4, remember that the a and b don't change. So in this case, my a is 2 and my b is 3. I should say even plus or minus 2, but you get the idea. So, well, it's a is 2, b is 3. So in this case, let's see, and my x squared comes first, okay? So that tells me that it's horizontal. All right, and I'm just gonna hold on, let me make some more marks here to make this a little clearer. Okay, here we go. My center is at 0, 0 because I don't have any minuses and stuff. So I've got my center. I've got my vertices and my co-vertices. I don't really do a whole lot with these co-vertices, remember. If I wanted to just quickly like boom, boom, I could like just stick in some of these, but I'm not going to because of course I can't make them. So, but this is where for the graphing where the asymptotes come in. But let's see, hold on, we've got our center. Let's write down our vertices are going to be over 2 up 0 over -2 up 0. Our co-vertices are over 0 up 3 over 0 -3. I have to tell the foci. So this is one that we haven't done yet. So this is, let's do the foci, okay? For the foci, remember that c squared equals a squared plus b squared because we have to find our c to do foci. So c squared equals a squared plus b squared, which is 13. Sorry, c squared is 13. Don't forget then, c is the square root of 13. And then those foci are going to be on the same axis as like whatever, like if it's my x first, then my foci are on the x-axis. If my y is first, then they're on the y, and they'll actually be outside of it, okay? But you don't have to plot them. Basically, we can just say the foci are over negative radical 13 up 0 and positive radical 13 up 0, because it's both distance from the, what's it called? The center. All right, so we've got a lot of, we've given all the information, but we're gonna finish, oh, we have to do the asymptotes, and that's gonna help us finish our graph nicely. I'm gonna erase just this where we just listed all this stuff. So we can do our formula. All right, so if I'm gonna do the asymptotes, here's my formula for the horizontal one. We're doing y equals plus or minus b over a times x minus h plus k. All right, so y equals plus or minus b over a, in this case, that is 3 over 2. Remember, these are b squared and a squared, so you have to take the square root, times x minus h. Well, in this case, my h and k are 0, so I just end up like that. Y equals plus or minus 3 over x, because k is 0, h is 0, because my center is 0, 0. All right, so then I'm gonna plot this. You guys know how to graph a line. Essentially what we have here is y equals 3x, sorry, y equals 3 halves x and y equals negative 3 halves x. Okay, let's think back to graphing. Let's do the first one right here. My x-intercept, sorry, my y-intercept is 0. And to graph, I go up 3 to the right 2. Or the exact opposite, which is down 3 to the left 2. And for asymptotes, we're just gonna do dotted lines like this. And what these asymptotes do is they guide our little hyperbola scoops. And then this negative 3 over 2, again, starts at 0, 0, but this time, because it's negative 3 over 2, we go down 3 to the right 2, or the exact opposite, up 3 to the left 2. So that gives our framework for our scoops. Now I'm going to try to do this and not make a complete disaster out of this. So we go here. It's not a total disaster. It's just oh, can't touch my asymptote. There we go. Okay. You understand graphing a parabola? We're going to do a harder one, or a hyperbola. Oh, why can't I say that right? We're going to do one more, a vertical one, and then we're going to write equations. But we only have 2 minutes in this room, so let's exit. And I'll meet you. I have it queued up, so I'm hoping to meet you faster than I usually do. We'll see how that goes. Okay, so I'll see you in a minute.